Here's our practical. So in front of us we have two just regular old fans. One is plugged into the wall and has power going to it. We're going to call this one our impeller, and we're going to call the power going to it our engine. The one on the right is going to be our turbine, and this one is not plugged in. So this one does not receive power directly from the engine. So when we start our engine, we can see that the movement, in this case, of the air that goes from one fan to the other causes the opposite fan to move. Now you'll see that it doesn't necessarily rotate at exactly the same speed. There is some power loss here, but there is power that is transferred from one side to the other, just like in the transmission. So this side over here would be our impeller, driven by the engine. And this side over here would be our turbine that drives the input shaft of the transmission. So these two things work together. So the fluid that passes through these veins, once it does that, once it passes through the impeller or the pump into the turbine, it causes the turbine to move. And here's the cool part about what a torque converter does. Like say, for instance, when you go to a stoplight. So you're going to a stoplight and you're slowing down and you stop the vehicle. So the engine can still run, but it's just not turning the turbine at this point. But then when you go to take off, there you go, it can start again. Now you notice that when I let go of the second fan, what would be the turbine, it took a little while for this to go. That's because you really need like an oomph to overcome the static inertia of the vehicle. So a car, when it's just sitting there, has a lot of weight to it. And that weight equates to what's called a static inertia. So that car, now that it's at rest, does not want to move. So you got to get it moving. But in order for this to work more effectively and more efficiently, we use the stator.